and welcome to Technically Speaking, where scientists and engineers come together to chat about a common interest, share knowledge, and satisfy some curiosity. I'm Ellie, and I'm joined by Jasmin and Laura to talk about direct capture of carbon dioxide from the air. So I, as I said, know nothing about this, but Jasmin, you're somewhat of an expert. Can you tell me more?
So direct air capture is different to other forms of carbon dioxide removal in that it's removing carbon dioxide directly from the air itself. So is this different to like carbon capture storage, which is focusing on removing carbon dioxide from like combustion flue gas?
Perfect. And Laura, you're not an expert in the same way as Jasmin, but what's your interest?
So I am in the energy industry to an extent currently, so I work for the National Nuclear Lab as well as doing some freelance science communication. And as far as I'm aware from both of those jobs, there are lots of industries that will be really difficult to decarbonise, so to not have any carbon or carbon-related emissions going into the atmosphere. And from what I've heard, the sort of carbon capture that Jasmin has just talked about could be essential for meeting some climate change targets.
Yeah, I mean, it sounds quite scary to me, but let's get into it. Jasmin, kick us off. Tell us all about it. Let's talk about the tech. Let's talk about some definitions.
Yep, so direct air capture is the removal of carbon dioxide directly from the air. It does this by using a process. So like you use chemicals that will react with the carbon dioxide to remove it from the air. And this can be either be a liquid chemical or a solid chemical that you can use. Once the carbon dioxide has been removed from the air, you then need to release it from the chemical that's just absorbed it. And you would typically do this by heating it up. So you heat up the chemical and then that releases the carbon dioxide in a high purity stream. You then separate that out and you can either send that off to be stored in deep geological facilities for carbon capture and storage, or you can actually use it. There are projects for direct air capture, but they're still fairly on the smallish scale. So I think for actual use of carbon dioxide, it's more around like using them in greenhouses to enhance productivity. And there are other ways you can use the carbon dioxide. So in like chemical manufacturing, you can use it to make synthetic chemicals, or in other processes that need carbon dioxide, such as in like breweries where you need carbon dioxide to make fizzy drinks. In a nutshell, that's what direct air capture is.
So you mentioned before that there was solid and liquid ways. You need some sort of chemical substance to pull the carbon dioxide out of it. So how does that work?
For example, the solid type of chemical that you would use, it's more similar to like what you would use in conventional carbon capture and storage. So you use an amine chemical that reacts with the carbon dioxide. In solid direct air capture, you use what's known as kind of like a filter. So you can imagine like the air passes through a filter and then you need to like heat up the material in that filter to release the carbon dioxide. In liquid, it's a different chemical. It's potassium hydroxide. That will react with the carbon dioxide, and then that goes through a further series of chemical reactions, because from the reaction of carbon dioxide with potassium hydroxide, you then need to go on to create calcium carbonate and calcium oxide, and then that eventually decomposes into carbon dioxide.
Oh, I have questions about the potassium hydroxide, but amines, I came across those in my PhD, because my PhD was looking at a very specific type of carbon capture technology that was in development, and I think the amines were of particular interest because they had a nitrogen atom attached to the other atoms, kind of similar to ammonia, but that nitrogen atom had a charge that was quite favourable for attracting the oxygen in the carbon dioxide molecule to it, I think.
Yeah, that's also from my understanding, it's how amines work as a way of removing carbon dioxide from basically anything.
Where are we getting the amines from in the first place? Is someone making them? Are they naturally occurring? Are we sourcing them from somewhere?
I think Laura would know better. I just know that we get them from the chemicals industry.
You're the chemical engineer.
I know, but I don't work on how they're made.
It's not something I've researched actually, but I would assume that it would involve some sort of reaction of ammonia with some other carbon-containing material. So you've got to think about where that feedstock comes from and where you're getting all the materials, and then the energy intensity of that process as well.
Yeah, I was just going to say, because you said, Jasmin, about heating up the like filter. So presumably that is also requiring energy of some kind, be that from like the burning of fossil fuels or from like wind or whatever?
Yeah, so in the solid version, the temperature is much lower than in the liquid. So in the solid, you can use just electricity, which can be renewable electricity, but it depends on like how you get your energy. In the liquid, you can also potentially use entirely electricity, but because it's a much bigger heat demand, you would typically use like natural gas for heat or other forms of heat rather than electricity by itself.
And how long is this process taking? Is this, say we want to extract a ton of carbon dioxide from the air. How long do you reckon that would take? Is it hourly? Is it 24 hours? Is it 3 weeks?
It's actually pretty quick. So these direct air capture plants, at least the bigger ones that are currently in operation, they've got pretty big capacities. The two companies that are currently leading the market right now, they are called Climeworks, who are specialized in the solid type of direct air capture, and there's also Carbon Engineering, who are specialized more in the liquid. So the liquid type has bigger capacity, so that means like because the plant's bigger, you can remove more carbon dioxide, whereas the solid, it's more of a modular design, so the capacity is much smaller. With the liquid, the current plant that Carbon Engineering has, it has a capacity of 1 million tons of carbon dioxide per year. It's a lot.
So this is being done? This is being done across the world already? We're already doing this process?
Yeah, well, not exactly across the world, but in certain countries where these companies are based. So Climeworks is Swiss, and they have projects in Switzerland, but also one in Iceland. It's quite interesting. And Carbon Engineering, they are Canadian. Right now, there are no like UK specific direct air capture companies or projects that I'm aware of. We could potentially see UK based carbon dioxide companies or projects in the upcoming years, just because there are certain sectors that are really difficult to decarbonize. So you kind of need to have direct air capture as a way of offsetting the emissions so that our net emissions are going down the way that we need them to be.
But if we've got big industry with this CO2 emission, would it be better to use carbon capture bolted onto their plants rather than waiting for it to get into the atmosphere and then removing it?
Yeah, so for some sectors like cement, so cement's interesting because most of the CO2 that's produced by it isn't actually from any like fossil fuel use, rather it's from like lime or calcium containing materials just decomposing and releasing carbon dioxide into the atmosphere. So for like stuff like cement, it would be more beneficial just to have carbon dioxide capture and storage just attached to it. But there are other sectors which would be slightly more difficult to decarbonize, so like road transport. Like we could go all electric, but it really depends on a lot of stuff that the normal person doesn't really have much influence on. The UK's industrial sector and clusters, they have to meet certain emission reductions by 2035 and by 2050 so that the sector as a whole is in line with what the UK needs to meet its law-abiding net zero pledges. And basically by 2050, emissions from the industrial sector have to be reduced by at least 90%, which is a lot.
Yeah, but I like the question from the audience, which is specifically they're asking about what our views on Taylor Swift's massive emissions of carbon dioxide from her extensive use of her private jets are.
As a Swiftie, I have many thoughts on this.
Yeah, but that's one that's hard to decarbonise, right? Because you need a high energy density for the fuel for the plane.
Yeah. And we've had like a previous live episode where we had people from a company that were making an alternative aviation fuel on. You can like try to decarbonize aviation by using like synthetic fuels, which are made from using carbon dioxide and hydrogen. But the carbon dioxide is circular in quotation marks, in that you get it from direct air capture. The carbon cycle's really complicated sometimes, but basically because it's a renewable or circular source of carbon dioxide, when you end up emitting it from when you're burning the synthetic aviation fuel, it doesn't add more carbon.
Because you've already captured it to make the fuel in the first place.
Yeah, you've already captured it, yeah.
Is Taylor Swift investing in that technology? Does anyone know?
I mean, she's got the money to, right? Maybe we should pitch it to her.
She could, like, fund our research, or fund my research.
At the Eras tour in August, I'll see if I can mention that.
Yeah, just, like, have a big sign that blocks everyone's behind you's view saying, fund our research, please, Taylor Swift.
I mean, I'm way up in the gods, so I don't think she'll be able to see. But you mentioned that we might see, like, UK direct carbon capture companies popping up, or it might be more common in the next 5-10 years. What is their sort of land use footprint like? How does it compare to something like a nuclear power plant or coal or, you know, one of those massive oil rigs that you see in the middle of the ocean?
For like a direct air capture plant, it depends again on like what capacity you want and also whether or not you go for a solid or a liquid. So the solid is a modular design, so their land footprint is smaller. So they're good if you want like small scale, or if you also, because they're basically like, the way to describe what they look like is if you imagine like a freight container or a crate that just has a fan inside and then a membrane behind it. That's basically what they kind of look like. So they could have quite a small land footprint in that you can just stack one on top of another.
Yeah.
But like, because they are modular, when you get to certain sizes in terms of how much carbon dioxide you want your direct air capture plant to remove, at a certain point it becomes more economical to just go for liquid, which has a bigger land footprint and also bigger energy usage, but it is more economical to just go for liquid direct air capture if you want to like remove carbon dioxide in magnitudes of like millions of tons per year.
I saw a research review that mentioned some of these things. It was published a few years ago, and they cited their sources, but I don't think it was hugely comprehensive. But the statistics they mentioned was that to use a direct air capture plant that's been engineered by people, so using either the liquid or the solid filters that you mentioned, you'd need a land area about 6.6 times the size of New York to remove a certain amount of CO2 from the atmosphere over a certain time frame. But using just trees, so doing it naturally with forests, would require a land area almost 7 times the size of all of the United States.
Oh, wow. Yeah, because I was going to ask you, because we've talked a lot about this tech, right? But carbon capture or carbon conversion is literally what trees are doing the whole time.
Yep, photosynthesis.
So do we even really need this? Like, are trees not just doing the work for us?
Trees are nice and they're very pretty to look at and they're very useful, but the amount of carbon dioxide that they remove per individual tree is just so much smaller than these engineered alternatives. Depending on the type of tree species, the amount of CO2 that they can remove per year, it's like anything between a little over 1 to 12 kilograms of CO2 per year per tree. So it's pretty...
1 to 12 kilograms seems, I reckon, not that bad per tree.
Not that bad, but compare that with millions of tons.
What resources do a tree need? They require quite a lot of water in comparison to engineered methods, apparently.
Also land.
Yeah, it was like Laura was saying that you need a phenomenal amount of land.
They do have the benefit of being a habitat for animals and creatures, though.
Yeah, they do. So if anyone is to buy carbon offsetting credits, for example, if you're going to take a flight and you want to feel better about flying, you can buy carbon credits to offset your emissions, and usually it's from like forestry management projects. The thing with any kind of forestry management project or like tree planting project, there's a really high uncertainty in how much carbon dioxide is going to get removed, because a lot of it depends on how well the tree grows, how quickly it grows, and whether or not it actually lives past a certain age. The longer a tree lives, the more carbon dioxide it can remove over its lifespan. But once they've passed their juvenile stage, the rate at which they can remove carbon dioxide just really plummets.
Oh, I see, because they're growing so much more when they're younger.
Yeah.
So, but yeah, trees also have other benefits.
Yeah, they do.
I was going to ask you about waste as well, because trees have very little waste. I suppose you can count the leaves in the autumn, all the rest of it. Is there waste involved in direct air capture?
Yeah, so you get some chemical waste. So for the solid, after a while you would have to renew the amines and the other chemicals, basically replace the filter in the direct air capture unit. You would have to replace that every so often. But with the liquid, you would get waste in the form of, I think it's calcium carbonate, or it might be calcium oxide. It's one of the two. You would also have like waste from the potassium hydroxide solution that you're using, because if you're doing any maintenance on your facility, you will need to like drain that and then pump in some new potassium hydroxide solution.
So, I mean, it's like anything, isn't it? It has pros and cons.
Yeah.
And there's always waste to like chemical processes.
It doesn't sound like it's particularly difficult waste to deal with, though. I might be wrong there.
It's not radioactive.
Yeah, no, it's not radioactive. Yeah, I think with potassium hydroxide, an industrial wastewater plant or industrial wastewater facility should be able to handle it. But with the solid, it really depends on what chemicals they use, because I'm not entirely sure how you deal with the waste management of amines in particular, especially when they're in a solid form.
What's also interesting is that should we even do this? Obviously, carbon emissions are going up. They're much higher. It's because of human activities largely. And things like deforestation, things like industry expansion, massive urbanization. Should we be investing not in taking carbon dioxide out of the air in this way, but in lifestyle changes for people? You mentioned lots of industries are very hard to decarbonize. Should we be not flying? Should we be reducing our agriculture? What do you guys think?
I think Taylor Swift should definitely be flying less.
On the Taylor Swift point, right, she can't fly commercial. That's just not an option for her. She can't. She's too famous. She would get absolutely badgered by every single person on the plane. There's no way. She couldn't walk through an airport safe. The amount of stalking and harassment she's dealt with.
Hasn't her legal team filed something against? So there's a US university student who has a Twitter account that he basically tweets where people's private jets are flying to. And didn't Taylor Swift's team file a cease and desist order against him?
Yeah, I think they did. But it's a privacy issue, right? If I was Taylor Swift, I wouldn't want people knowing where I was at all times and tracking my whereabouts. It is a bit creepy.
But yeah, I mean, lifestyle changes and just changes to the way that we use energy and that we eat food would make an impact. It's just that the way that if we want to maintain our current lifestyle, so certain things would need very drastic changes very quickly. So for all the chemicals and materials like metals, cement that we use, they would need really drastic changes really quickly, and don't really see it happening. And also especially if we focus on the UK, I mean, industry's kind of dying to a certain extent because Tata Steel are closing. I think it's Tata Steel. They're closing their South Wales facility.
They're not closing it.
Are they not closing it?
They're stopping using their existing process, which produces a lot of CO2, and switching to an electric arc furnace.
Well, that sounds much better.
That sounds much better, yeah.
Well, no, because a lot of people will lose their jobs because it requires fewer people to run it.
Oh, okay, that's what it was.
It has less emissions, and it's recycling scrap steel rather than making new steel. But there isn't currently enough scrap steel in the world to
keep up with demand.
Yeah, exactly. So you still need to keep making virgin steel. And if it's not going to be made in the UK, it's going to be made somewhere else, which will have less stringent environmental and social targets.
Yeah, I'd also add that recycling steel is really difficult because there's a lot of different grades of steel, and when you're mixing two different grades of steel, you can often result in a really inferior quality of steel. So be interested to see how that goes for Tata Steel.
Yeah, it sounds like some very different challenges. But I think that also feeds into my point of you were saying we could change habits and we should change habits, right?
Yeah.
But the easiest way to meet the climate targets, so we only have a certain amount of emissions going into the atmosphere, is just to kind of stop doing stuff.
Yeah.
And that's not how modern life works.
No.
That would mean a lot of people would not be able to have jobs. What would I not be able to do? Not much, because I don't drive. I cycle and I get the train everywhere. But for some people, you can see that you wouldn't be able to get anywhere at all. Getting food would be a challenge, even just heating your home. I have a gas-fired boiler. If we don't have a gas network anymore, I'd have to change my heating system. There'd probably be a limit on how much electricity we can supply to homes. You'd have to decide who gets electricity and who doesn't.
Ooh, back to the rolling blackouts.
Yeah.
Yeah, it really is an extreme. In terms of emission reductions that we would need to see, and what kind of behavioral changes we would need. 2020 saw a really big drop in emissions, but that's because no one could go anywhere or do anything.
Yeah.
So we'd need that kind of level of changes to lifestyles to really make any dent towards meeting our net zero pledges by 2050. But obviously 2020 was miserable.
Yeah, no one could do anything. That's the thing, isn't it? It's the lifestyle changes are so extreme, no one wants to do them.
I quite liked summer 2020 because there weren't very many cars on the road.
So you could cycle anywhere you wanted.
Exactly.
You also live somewhere where it's rural. I was living in South London in a flat and it was miserable.
I can imagine. I heard stories. It did sound quite grim. I think I would have struggled as well. There's a question in the chat that kind of feeds into this in the Q&A about why are we spending all this money on other projects that aren't necessarily saving the world when we could be spending it all on trees and CO2 capture devices. I guess an example from an earlier episode is investing in space travel and space exploration.
Oh, yeah.
Should we be doing that now? Which is also contributing to emissions, although it's quite small.
Yeah, we had this debate before about if you were in charge, right? You've got the money to decide and the political power. Are you giving it to things like tree planting, environmental projects, direct air capture? Or are you spreading the options across, the NHS? Obviously, health is very important. Obviously, agriculture is very important. You can't sort of negate all other aspects for this one thing. Or should we? What do you guys think? Is this the most important issue?
I would say it's definitely up there and should probably rank higher than space travel or, this might be a controversial answer. There was that project we talked about where some lab somewhere else in the world has managed to get funding to bring back the woolly mammoth.
Oh, yes.
Is that the one to make the woolly mammoth meatball?
Yeah, colossal.
I'm not sure, but I think we agreed that the idea of bringing back the woolly mammoth is probably fairly stupid.
Also, where's it going to live? Like, it doesn't have a habitat anymore. That's why it went extinct.
The idea of all the genetics research that would enable, that could improve people's lives, was probably quite worthwhile. So I would say there should be more money spent on tackling climate change, but it's not just about the research, it's about changing habits and developing more infrastructure to do it.
Yeah.
But there are other projects like healthcare and tackling inequality that are just as important. They're all part of sustainability, essentially.
Yeah, and it's knock-on effect, isn't it? If we invested lots of money in this, who knows what else we could find as a byproduct? You know, what would those waste amines be used for? We don't know yet. Potentially, we don't have enough research to say.
Yeah, and we could be using a completely different material in 10, 20 years versus what we're using now.
Yeah, that's so true. We don't know how the technology will move on. Maybe we'll get even better at direct air capture and then simultaneously solve global warming and climate crisis while also discovering the potential use of amines in healthcare. Who knows?
Yeah, who knows?
Well, I think that sounds like a good place to leave it. We've covered everything from what direct air capture is to if we should even use it and whether Taylor Swift could be a future investor in the direct air capture industry. Thank you for listening to this episode of Technically Speaking.
The views expressed in this podcast belong entirely to the person that said them. They do not represent any industry or organisation. If you enjoyed listening to these views, it would really help us out if you could rate us, leave a review and tell a friend. This podcast was sponsored by no one, but if you're interested in funding us to continue to have frank discussions about science and engineering, please get in touch.